Welcome to the Solving Quadratics review video. So we're going to go through each of the solving methods, and in this case a little bit of the completing the square, just kind of first step, right? And so it shouldn't take us too long. It's a pretty short review. Okay. So first problem is saying for each problem state the value of c that will complete the square. So our job is to use completing the square. So this is a good time to remind you of one of the formulas that is necessary for the solving methods for you to know, and that is b over 2 squared, right? What we said for completing the square was that the c value, right, is always equal to whatever the b value is divided by 2 squared, and that will give you an expression that is a perfect square. That's why this is called complete the square. So I'm going to take my b value, which is 4, and say if I do 4 over 2 squared, right, that would be my c value. And so for this problem, that would be 2 squared, which is 4. So first problem, letter A, is just 4. Okay. Second problem says 11 in the middle, so I'm going to do the same thing and say 11 over 2 squared. Okay. So now you have two options, and again, if you're taking a quiz, you have to kind of know about both of those options so you can select the one that matches the format of the quiz, right? So our c value is going to be 11 over 2 squared. If you turn this into a decimal, you're going to get 5.5 squared, right? And so then you would have to do a little bit of calculator work here if you don't know what 5.5 squared is. So 5.5 squared is 5.5 times 5.5, so 30.25, right? That would be your answer. So C is equal to, okay, 30.25, okay? So again, you have to know how to do this in both formats. So here's kind of the other way, right? You might also just square the fraction, right? So no calculator necessary. 11 squared is 121. 2 squared, right, that's a 1, right? 2 squared is 4, right? That's also a possible answer. If you do 121 divided by 4, you're going to get 30.25. No calculator necessary. Okay, so either of these formats is correct, but remember you have to kind of identify the one that is given on the quiz. Okay, problem number 2 is the square root method. Okay, so let's just remember when we use the square root method, because on a quiz you might just be given a problem and say, hey, use any method you want, right? So for this, if you notice in both of these problems, if I grab my highlighter, okay, the letter or in the expression, the x value only shows up one time, right? If I compare that to even the previous problems that we did where it showed up 2 times, right? These would be problems that I could not use the square root method on because there are 2 x values in the problem. In problems like letter A and B on this slide, you can see that it only shows up once, right? That's when we can use the square root method, okay? What the square root method says is that if there's only one x value, right, you're going to figure out what is being squared. So in this first letter A, it's just the x being squared. You're going to get that by itself. So let's do that. Okay, so I'm going to start off when I'm trying to get something by itself. We always want to undo addition and subtraction first. So I'm going to add the 88 to the other side. So if I say 5x squared, if I add the 88 to the other side, that's going to be 100. Okay, the next thing we always get rid of when we're trying to get the squared by itself, or anything by itself, is anything being multiplied or divided. So that's this 5. So I'm going to divide by 5. Okay, so 100 divided by 5 would be 20. Okay, and now that the squared is alone, we're going to square root both sides. Okay, and so I'm done. I got x by itself. I've solved the equation, right? I do have a little bit of cleanup to do though, because again, if you're thinking about a quiz, all of your answers will always be in simplified form. So when I take the square root of 20, I'm not going to leave it because I can simplify that by removing the perfect square. Square root of 4 is just 2, right? So I can say 2 root 5, right? That is the simplified version of the square root of 20, okay? Please do not forget, however, that 2 root 5 is not the only answer, because anytime I square root a squared, like I did here, the other side will always have a plus or minus, right? So, because it's possible that I squared positive, or it's possible that I squared negative to get that answer. Okay, so plus or minus 2 root 5, that would be our answer. Okay. Problem letter B is the same thing. We're going to get the squared alone. Okay, let me grab my highlighter one more time. Okay. So I'm going to say, ooh, not the crayon, there we go. All right, so I'm going to do the same thing, but I'm going to say the thing that I'm squaring is x minus 7, right? It's not just x. It's this entire parentheses that's being squared, right? So when I take a look at this problem, I'm going to do the same thing. I'm going to get rid of the addition and subtraction. So let's start off with that. Now I'm going to get rid of the multiplying. This 3 is being multiplied by the x minus 7. Okay? Notice what I'm not doing here is distributing, right? There's always the temptation when there's a number out front of a parentheses to want to distribute it inside. You cannot do that because the parentheses are being squared, and PEMDAS says that you should always do the squared first. So since we're not able to do the squared because this is an expression, not a number, we can't multiply by that 3. Okay, so here's where I'm at. Okay, but that's okay. If you notice over in this problem on letter A, we had something squared equals something. Over here we have something squared equals something. Right, so it's the same type of problem. It's just that the thing we're squaring is a little bit more complicated. Okay, so I'm going to square root both sides just like I did in the previous problem, and I'm going to get an x minus 7. Okay, and now here's where things get a little different, right? Just like I did over here, I saw the square root of 20, I simplified it as much as I could. Well, now I have the square root of negative 4, so let's kind of do that right here. Okay, how do I simplify the square root of negative 4? Well, the square root of negative 1 gets its own parenthesis, and the square root of 4, right? And so the square root of 4 we know is 2, and the square root of negative 1 is just I. Okay, so I'm going to say this is 2I, and I'm not going to forget about the plus or minus, okay, because every one of these problems has a plus or minus. And then to get x by itself, we do have an extra step here. We have to add the 7 over. So x is going to be equal to 7 plus or minus 2I. And that would be our final answer. Okay. All right, so for the factoring method, remember the goal here is really just to set things equal to 0. So for this letter A, right, we're going to subtract all the stuff that's on the right over to the left, right? And I'm making that decision because 4x squared minus 2x squared gives me a nice positive number. And I always want to try to keep the first value, the A value, positive if I can, right? So I'm going to move everything to the left. So it's going to be 2x squared. And then when I do negative 3 minus 10, I get negative 13x. Right? And then when I do 10 minus 55, I get negative 45, right? So this is going to be my my set equal to 0 version of the equation. Right, now my job is to factor this, right? So if I'm going to factor this, I'm going to say my AC value is negative 90. The B value that I have in the middle is negative 13, right? So my job is to find numbers that multiply to negative 90 that add up to negative 13. Right? And in this case, those values are 18, negative 18 and positive 5. So I'm going to say 2x squared. And instead of writing this, I'm going to say minus 18x plus 5x minus 45 is equal to 0. Right? And I'm doing that because now I can take this expression and use the grouping method on it. Right? So I'm going to say first group has a 2x in common, and it leaves behind an x minus 2. Okay? I'm sorry, an x minus 9. Okay? And my second group has, it looks like a 5 in common, and also leaves behind an x minus 9. Okay? So if I regroup now, here's what I get. 2x plus 5 are the outside values. Okay? And then I have a common x minus 9. Right? Those are the leftovers. Right? And now I've done it. I factored the expression. Okay? The factoring method says after you've done that, then just set your factors equal to 0. So I'm going to say either 2x plus 5 is equal to 0, or x minus 9 is equal to 0, and I'm going to get two answers. So this one is negative 5 over 2, which would be negative 2.5, and then this one gives me a 9, right? So that was going to be two solutions. Okay, we expect squared problems to have two solutions, so that's a good result. Okay, letter B, same idea. X squared minus x minus 72 is equal to 0. Okay, and I'm going to do the same thing. The nice thing about this one is because there's nothing in front of the squared like I had over here, I can use what we call this, I call it the simple method, right? I can just go right to, kind of skip all this middle stuff and go right to this answer because I know that x squared can only be x and x, right? And I'm going to break up 72 into what multiplies to negative 72 that adds to negative 1, in this case, negative 9 and positive 8, okay? So I can just set these equal to 0, x minus 9 equals 0, x plus 8 equals 0, okay? And I get two answers, right? 9 and negative 8, okay? There it is, okay? So that one's a little bit more straightforward because the factoring was easier, but the actual solving process was the same. Set it equal to 0, factor however you have to factor, set your factors equal to 0, solve each of those factors, right? So we get, in both cases, two solutions, okay? All right, number 4, completing the square. Okay, so our job here is to use that b over 2 squared like we saw in problem number 1, right? And I always, well, both of these are set equal to 0, so we don't even have to think about that. Okay, so b over 2 squared for first problem is negative 12, okay, over 2 squared. Okay, so that would be negative 6 squared, which would be positive 36. Okay, so what we're claiming is that I don't want there to be a 7 here. I want there to be a positive 36 in that C value spot. Right, so I'm going to move the 7 out of the way. I'm going to put it on the other side, and we're going to say x squared minus 12x, move the 7, so it's going to show up on the other side as negative 7. Okay, and then we just found out that I want the C value to be 36. So I'm going to do that. I'd like there to be a 36 here. Okay, and that means that on the other side, I need a 36 as well. Don't forget to balance your equation, right? So the right-hand side, pretty straightforward. Negative 7 and 36 makes 29. Okay. On the right-hand side, what we just did was we put that 36 there so that we completed the square, which means this expression is something squared. And if you notice, negative 6 times negative 6 makes 36. And then if I add those together, I get negative 12. So this is going to be x minus 6. Okay. I have mentioned several times, if negative 12 is in the middle, if you cut that in half, that's always what you will have inside of your expression here. Okay. So I'm almost done. If you notice, this looks a whole lot like the square root method now. Not a coincidence. We just completed the square. Okay. So I'm going to square root both sides. X minus 6 equals, don't forget your plus or minus the square root of 29. Okay, and then the only thing I have left to do here is to add the 6 over, and I'm going to get 6 plus or minus the square root of 29. Okay, so that's my solution. Okay, all done. I don't have anything left to do, nothing to simplify, problem over. Okay, letter B. Okay, same idea, but here's the catch. Okay, for letter A, the number in front of x squared was 1. Okay, in order for us to use this b over 2 squared formula that we used, A must be 1. Right, so if you notice, this one's got a 2. The first thing I need to do is GCF out that 2. Okay, done. Okay, and then I can, in this case, just divide it away. Remember, if there's nothing attached to that 2, I can just say divided by 2 on both sides, right? And I'll end up with a 1, right? That cancels. X squared minus 4x minus 3 equals 0 divided by 2, still 0. Okay, so from here on out, everything's exactly the same, right? We're going to figure out what we want to be as the C value. So let's just kind of do this mentally. Negative 4 divided by 2 is negative 2. If I square that, I get positive 4. So I would like there to be a 4 here. So I'm going to do that. X squared minus 4x. Let's move the 3 to the other side, right? And then I'm just going to add 4, right? I did b over 2 squared, and I decided I wanted there to be a 4 here. Okay. So now the left-hand side is something squared. Okay. And let's use the kind of method I talked about over here. If I take half of the b value, right, that in this case is negative 2. That's what shows up in the parentheses. Okay. And so I'm done, right? I got square root both sides. Okay. X minus 2 is equal to plus or minus, don't forget it, square root of 7, and then I can add the 2 over. Okay, so 2 plus or minus the square root of 7. And that would be your answer. Okay. Again, not super nice looking, but that's our answer. Okay. All right, moving on. We got one more solving method left. Okay, the quadratic formula. So let's start off by writing down the quadratic formula. I'm going to use this little space up here, right? So I'm going to say the quadratic formula says x will always be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. That's our formula. Okay. Our a, b, and c values come from setting the problem equal to 0. Okay, and then whatever the a, b, and c value, which is x squared, x, and constant, that's what we'll do. Okay. Again, my goal here is always to try to get x squared by itself. So in this case, I'm going to decide to subtract all of this stuff on the left over to the right. Okay, so let me do that. Okay, so it's going to be 0 on the right. If I subtract the 3x squared, I'm going to get 1x squared. Okay. If I add the 11 over, I'm going to get positive 3x. And then if I subtract the 22 over, I'm going to get negative 4, right? So this is the expression that I would like to plug into the quadratic formula. So that means for this problem, we're going to take the values in front of x squared, which is 1, that's my a value. B is in front of x. C in this case is by itself, that's the -4, right? And we're going to plug that information into this formula. So this is what it will look like. We're going to say -3 plus or minus the square root of. Here's something to be very careful about, okay? Whenever you plug in the b value, I recommend you put it in parentheses. So I'm going to say 3 squared, okay? If you plug that into your calculator, okay, without the parentheses and it's negative, you'll probably get a wrong number. Okay, you got to be really careful. So I would just be in the habit of all the time putting your b squared in parentheses. Okay, -4, a is 1, c is -4. Okay, and then it's all over 2a, which again our a value is 1. Okay, so our job is just to simplify this. Okay, I always recommend starting off with this inside value, right? And again, I'll just do the work kind of like over here. 3 squared is 9, right? And then I treat this as -4, 1, -4. If I multiply those together, I get positive 16, right? So I'm going to say plus 16, okay? So that looks like a 25, right? So I'm going to say -3 plus or minus the square root of 25 all over 2 times 1, which is just 2, okay? So I'm not going to stop here, okay? Square root of 25 is something that simplifies. We know what that is. It's just 5, right? So -3 plus or minus 5 over 2, okay? And once again, I'm not going to stop, right? If this was a radical, I would have to stop because I can't combine -3 and a radical, right? But in this case, I can combine -3 and 5 using addition, and I can also do it using subtraction. So I'm going to go one step further and say this is really the same as -3 plus 5 over 2 and -3 minus 5 over 2, okay? Well, -3 plus 5 is 2, and 2 divided by 2 is 1. So I can get a 1 out of that. -3 minus 5 is -8. -8 divided by 2 is -4, right? So I got two answers as simplified as I can in this case because I could put those together, okay? All right, letter B, same idea. This one conveniently is set equal to 0, so I don't have to worry about that. So I'm just going to go right to the plug-in step, right? And we're going to say -b in this case is 10, right? So I'm going to say 10 plus or minus. Here's where you need to be careful, okay? I'm going to say -10 squared. So I'm going to show you the wrong way to do this. Don't write it like this. If you type this in your calculator, it will spit back a -100. But we know that -10 times -10 is positive 100. Okay, so if you type it in without the parentheses, you actually mean something different. Okay, so 4, A is 3, C is 30, right? So I'm going to say all over 2A, which in this case 2 times 3. Okay, so let's see what happens when we simplify our radical here, right? We're going to end up getting 100 minus, and I believe this comes out to be 12 times 30, which is 360. So 100 minus 360 would be -260. Okay, so I'm going to say this is -260 all over 6. Okay, so we're kind of done, right? Like we simplified the radical. I'm sorry, we simplified what was in the radical. Now we just have to make sure we can we simplify any parts of the radical that still might be there. Okay, so let me grab my calculator real quick. We got to do a quick search. Okay, so we're going to say 260 definitely has a 10 in it, which means it also definitely has a 5 in it. And then it might actually have a 20 in it, right? It does, right? It's got a 20. So it looks like 4 is the best I can do. So I'm going to take a 4 out of this radical. So I'm going to take this -260. Okay, let's go to our middle space here for some side work. Instead of writing -260, we're going to say that this is a -1, a 4, right? Because I can square root 4. And then if I divide by 4, it looks like I'm left with a 65, okay? So I'm going to say 65, which does not have any perfect squares, okay? And so when I simplify this, it looks like I'm going to get a 2, an I, and a root 65, okay? So I'm going to rewrite that. 10 plus or minus, instead of this expression, I'm going to write 2I root 65 over 6, okay? And now I have one more step of simplifying for this problem, right? I can't obviously combine the 10 with this second expression because of the radical, but I can take the 10, the 2, and the 6, right, which are all kind of outside values, and I can divide them all by 2, right? They are kind of fractions. Like this is the fraction 10 sixths and the fraction 2 sixths, and they would be something you would simplify, right? So I'm going to say this is 5 plus or minus 2i divided by 2 would just be I. Still root 65, I'm not touching that. And it's all over 3. This would be my final answer, okay? All right, we're almost there. Okay, we got one more problem, right? And this one's kind of word problem-y, right? It's not just solve, right? They're kind of just giving the problem in a different context, right? So this one says, what values of x will make f of x equal to g of x if f of x is expression and g of x equals 3x squared minus 4x plus 5, okay? All this means is they want you to set these two equations equal to each other and then solve, okay? Notice, however, there is no solving method, so when we get to that step, we're going to have to make a decision about what method we want to use to solve this. So let's start off by setting them equal to 0, or setting them equal to each other, because it says, when is f of x equal to g of x? So I'm going to say x squared plus 5x minus 9 is equal to 3x squared minus 4x plus 5, okay? All right. So I'm going to start off by, I always like to set this equal to 0 because I want to try to factor it. So again, I'm going to move all this stuff on the left to the right so that x squared stays positive. So this is going to be a 0. And it looks like I'm going to get 2x squared. When I subtract the 5x over, I'm going to get negative 9x. And then when I add the 9 over, it looks like I'm going to get a plus 14. Okay, equals 0 is already there. Okay, so this is just plus 14. Okay. So now I'm going to ask myself the question, can I factor this? Okay, and in this case, the answer is no, right? My AC is 28, and there's nothing that multiplies to 28 that adds to negative 9. So factoring is not going to work. Okay, so what I'm going to do is kind of go down the list. The next thing is the square root method. I cannot use the square root method because in this case, x shows up twice. The square root method can only show up once. Okay. I'm also not going to use completing the square because the number that's in front of x squared is not 1. And if I were to try to make it 1 by dividing everything by 2, I'd start getting ugly fractions like negative 9 halves, right? So I don't really want to use that. So it looks like everything else is not a great, use. So I'm going to go right to the quadratic formula. This is really just a quadratic formula problem, right? So I'm going to say, plugging in all the information, negative b in this case is positive 9 plus or minus the square root of, okay? And again, be careful, negative 9 squared minus 4 times 2 times 14, okay? All over 2a, which for us is 2 times 2, which I'm just going to write 4, okay? So if I multiply this together, this is positive 81 minus, right, and it looks like, what do we got? 28 times 4. Let's do 28 times 4 over here, right? So that's 32, carry a 3, 112, right? So this is 81 minus 112, right? And then 81 minus 112 is negative 31, right? All over 4, okay? So I simplified the radical, right? There's always x equals, right? The only thing I need to do is I don't like negatives in radicals. So again, here's your quick simplify of this. I'm going to say this is the same as negative 1 and positive 31, which I can't break down any further. 31 is a prime number. Square root of negative 1 is just I, right? So I'm going to say this is I root 31, and I can put that right where the square root of negative 31 is, and then I'm done. That's all we have to do with this problem, okay? So if they were to say, what values of x make these equations true? Well, only these two complex solutions will work, right? And that is your final solution, okay? So that's our 4 factoring methods, right? We have, our 4 solving methods. We have factoring, completing the square root method, quadratic formula, and then one problem where you're going to be asked to set the values equal to each other to find out when they're the same and pick which method you think is appropriate.